Hi, and welcome to this session on secure and compliant machine learning for regulated industries. I'm Stefan Natu, and I'm a machine learning specialist here at AWS, focusing primarily on financial services. I've helped a number of customers ranging from small and medium businesses to enterprises architect their ML workloads in a secure manner on AWS. Now in this talk, you as an ML administrator will learn how Amazon SageMaker provides you with the security, the networking, and the fine-grained access controls that you need to build a secure and compliant machine learning platform without you having to build that from scratch. In today's session, we're going to cover the following topics. First, we want to understand the requirements for secure machine learning. Then, we will discuss how Amazon SageMaker Studio, which is our fully managed integrated development environment or IDE, enables you to securely provision ML environments while removing a lot of the undifferentiated heavy lifting from building that yourself. For example, you'll see how SageMaker integrates with AWS security primitives such as IAM, KMS, and VPC. Now, just seeing slides is no fun, so we're going to include some demos for you to see how this works in action. And then finally, we're going to touch upon a topic on how you can automate the creation and provisioning of these secure environments and set up organizational guardrails to mitigate any potential threats and meet your compliance needs. Now, for each of the security themes I'll be covering in on the next slide, I'm going to provide you with some examples on how you can implement those security controls, but will by no means be exhaustive. However, I've included a number of resources that you can use to dive deeper into each of these topics. So let's get started. So in regulated industries such as finance or healthcare, as many of you know, unfortunately migrating an ML workload to the cloud isn't just a simple lift and shift. Individual services need to be approved by IT and security teams. They need to integrate with your existing IT policies, but also with your enterprise tooling that you might be using to manage user access or data or change management. Machine learning touches data stores, container stores, feature stores, and the machine learning tooling itself. And so ensuring that every service is compliant and meets your regulatory needs can be quite challenging. The first requirement that I hear frequently from regulated customers is ensuring that their compute instances and network traffic is isolated and that user and team-specific segregated workspaces are available. What that means is that your data scientists in different lines of business have access to their data, but not to others. Second, you want to ensure that user access can be federated or integrated with your existing tools, such as Active Directory or Okta. You also want to ensure that a data analyst who's running a deep learning training should probably not have access to GPUs. In other words, you want to authorize users to have permissions based on their role or their job function in your company. Now, regulatory requirements might dictate that depending on the data classification, you as a customer need to build some controls around how you encrypt that data. You also need to implement things like version control to track the lineage of any of the artifacts generated in the machine learning process. Why is this important? I've had a customer tell me that they deployed a machine learning model in production and the data scientists that did that moved on to another project. A year later, an external auditor required the company to explain that model's behavior. The team had to then go back and spend 2 weeks trying to trace the model's lineage back to the source code, as that was not well documented. Finally, you also need to ensure that any jobs or any APIs that you call are audited so that your administrators can mitigate potential threats such as data exfiltration. In order to allow data scientists to use certain services, you have to ensure that any non-compliant resources, when launched, are quickly terminated and state changes are reported. So with all of these requirements to think about, it's really no wonder that I've heard from a number of customers that building an enterprise-ready platform for ML can take them up to 2 years. So let's dive deep into each of these requirements in some detail, starting with compute and network isolation. Now, typically this means isolating your environment using a virtual private cloud or VPC and deploying resources within that VPC so that any AWS services or any on-prem resources that you might be using, such as a code or your package repo, can only be accessed without going over the public internet. Now, this can pose a bit of a challenge with machine learning because the machine learning space is evolving so fast, and ML engineers and data scientists need access to the latest open source technologies and tooling. So a common pattern is to lock down your dev environments or a sandbox environment, or dev or prod environments, but then have a separate sandbox account that's not connected to any customer data with relatively open permissions that you can use to upskill your data scientists. So let's see how SageMaker now allows you to fully isolate your ML environment. SageMaker is a managed service. So SageMaker Studio notebooks by default are internet enabled, and the notebooks run in a SageMaker service account, which is managed by AWS. To isolate this from the internet, you need to turn off the route from the studio domain to the internet gateway. Then, in order to be able to access, for example, your data sources or call SageMaker APIs, you need to set up VPC endpoints inside of your VPC. These VPC endpoints will allow private connections between your network and supported AWS services. VPC endpoints also support endpoint policies, and in our first demo, we're going to take a look at what one of those endpoint policies can do. SageMaker Studio will drop an ENI in a private subnet that you specify, which will allow it to call AWS services without a public IP address. For Studio in particular, you will need to create a security group that allows inbound TCP traffic to itself and associate that with a domain so that the front-end Jupyter server can communicate with the back-end kernel gateway. For machine learning, you might also consider including VPC endpoints for Amazon S3, CloudWatch, SageMaker, and SageMaker Runtime. So now let's jump into that first demo. In this demo, you will see how you can use IAM policies as well as resource-based policies such as bucket policies and endpoint policies to control ingress and egress traffic to your SageMaker notebooks. I've navigated now to the Studio console and I've used a CloudFormation template to set up my Studio domain in a private VPC. This domain has no internet access whatsoever, from the SageMaker service account or from my private VPC. In order to test that that's indeed the case, let's go ahead and make this call to the public SageMaker homepage. You will see that this call will time out, and that indicates that this Studio domain does not have any internet egress access. Next, let's look at the IAM policy that can be attached to the user profile. Recall that Studio user profiles can inherit the policy that is attached to the Studio domain, or you can attach fine-grained policies to specific user profiles. In this case, we have attached a policy that allows certain S3 actions, but only to a specific bucket called the Secure SageMaker Demo bucket. So let's try to upload this notebook to that bucket. And we can see that this upload is successful. But now let's try and run that same call, but upload this time to a different bucket, which is the Secure SageMaker Oregon bucket. And we see that that upload has failed because we have an access denied error. Now, in addition to IAM policies that can be attached to user profiles, resource-based policies can be attached to the S3 bucket as a bucket policy or to the VPC endpoint as an endpoint policy. Let's now modify the VPC endpoint policy to point to a different bucket. For that, I'm going to first copy the name of this bucket. I'm going to navigate over to VPC and click on endpoints, and I can see all of my VPC endpoints. I'm going to specifically click on the S3 endpoint and look at the policy that's attached to that, and I'm going to edit that policy. This policy allows certain S3 actions to the Secure SageMaker Demo bucket, but now I'm going to go and edit that policy and replace that with the Oregon bucket. Click Save and modify that policy and check that the policy has indeed been changed. And now I'm going to try and run that same call again, where I tried to upload this notebook to the Secure SageMaker Demo bucket again. And we see that that upload has failed this time, and I have an access denied error because the VPC endpoint policy does not allow me to make this API call. Let's go ahead and change the VPC endpoint policy back. Now, in addition to VPC endpoint policies, you have the option of adding S3 bucket policies. Let's take a look at a sample bucket policy. To the Secure SageMaker Demo bucket, we've attached the following bucket policy. This has a deny effect on these specific API actions unless the API actions emanate from the source VPC endpoint, which has been specified here. Let's take a look at how this policy would work in action. Now imagine that I am a rogue data scientist and I'm trying to get access to all of the data that is inside of this bucket. And in order to do that, I'm going to run the CLI call to try to download all of the data from that bucket onto my local laptop. Now this CLI call is made over the public internet and it does not go through the private VPC endpoint. So if I try to make this CLI call, you see that in fact an error occurs and the action is forbidden. In this way, you can use IAM permissions
in conjunction with perimeter network security controls and bucket policies to protect your data from being accessed by external users outside of your private network, as well as restrict who has read and write permissions to your data. Now let's jump back into the slide deck.
Now, a main benefit of SageMaker is that it offloads the heavy lifting of setting up and maintaining your compute infrastructure for machine learning. This also means, though, that when you launch a job in Amazon SageMaker, that job runs in the service VPC. So in the first demo, we've seen how you can isolate your notebooks. The next question is, how can I ensure that any data movement to and from those training and processing clusters only occurs from my private VPC? So during training, you can pass in the security groups and the subnets directly to your training jobs. SageMaker will create the ENI that we talked about in your provided subnet in order to communicate with resources in your VPC, such as your S3 buckets that might have your data that you need for training. As a best practice, you want to pass in these network parameters as environment variables in a Python file, so users can just pass in these parameters without having to know the actual value. The Python file can in turn access the VPC ID, the security group ID, and so on using a secure store like Systems Manager Parameter Store. Now, although we're showing an example using training here, the same actually applies during hosting. This time you specify network configs while creating the SageMaker model. When you create the SageMaker hosted endpoint, SageMaker will look at the network config that's attached to the model and create the ENIs for your model containers. In this second demo, you will now see how you can use a preventive control to ensure that you are always compliant with your IT policy of ensuring that data scientists cannot launch SageMaker jobs outside of your private VPC. So let's take a look.
For this demo, I have a notebook which I'm going to use to launch a SageMaker training job. First, let's look at the IAM permission that is attached to this user profile. You can see here that the IAM permission has a deny effect on these particular SageMaker API actions unless, by using this condition key, unless you provide the appropriate network configurations such as the security group IDs and the subnet IDs. So let's take a look at this IAM permission in action. In order to do that, I've already uploaded a MNest handwritten digits dataset onto my S3 bucket, and I've created a Python script which runs a TensorFlow training job. In order to run the training job, I'm going to first initiate the SageMaker TensorFlow estimator and specify certain parameters. You can see here that first, I'm not specifying any network configuration parameters. So let's see if this job runs by calling the estimator.fit call. And we can see that immediately we get a client error. And if we scroll down and take a look at the client error, we see that in fact the create training job action has an explicit deny on it from the IAM permissions. Now let's run exactly the same TensorFlow job, but this time providing the subnet IDs as well as the security group IDs that we need in order to run this training. And we can see that the training job successfully launches. Thus, you can see that by using IAM condition keys, you can enforce that your data scientists follow the required security guidelines in your organization when it comes to SageMaker training APIs or any SageMaker APIs to ensure that those calls are made within your private VPC. Now let's jump back into the slide deck.
Now let's talk about authentication and authorization. So in plain English, authentication means how do I know if you are who you say you are? And authorization means now that you are who you say you are, what actions are you allowed to take? So when it comes to authenticating users into Studio, you have two options, the SSO mode and the IAM mode. SSO integrates with AWS SSO, which allows you to create user identities or integrate with your existing user identities in Microsoft or Azure AD or in Okta. The other approach is the IAM mode. This is fully integrated with IAM in that you can create IAM users and to authenticate your users and roles for your users to assume. Alternatively, you can still federate your users using your enterprise tools and then grant them temporary credentials to assume those IAM roles. Now, regardless of how you manage your users, a common question that I hear from administrators is, how can I ensure that my users have least privilege access that is mapped to their role in the company or their job function? So in order to use SageMaker Studio in different capacities, whether you're a data analyst or a data scientist or a DevOps engineer who's going to be deploying models, you can grant IAM permissions to specific APIs. However, as a foundation, SageMaker Studio needs a service linked role to create an EFS volume and create and manage user profiles inside of the Studio domain. Next, the user IAM role needs pass role permissions to allow SageMaker to call services on the user's behalf, for example, Amazon ECR. The role that you attach to your training or your processing jobs, for example, needs to have permissions to create those ENIs that we talked about, as well as any permissions to encrypt or decrypt any data or any model artifacts that you might need. So with those base permissions out of the way, now when it comes to the machine learning itself, depending on the role or job function, you might want to allow different permissions. For example, developers who are just using notebooks for some lightweight data exploration need access to be able to launch apps. They can potentially run some lightweight processing jobs. They need access to their data, code, and package repos. Now, data scientists who are actually going to be running training jobs potentially need access to create a training job, a hyperparameter tuning job, batch transform job, or an AutoML job if they want to use a service like Autopilot. Additionally, if they want to tag and track their experiments and their trials or their training jobs using the SageMaker experiments capability, they need permissions to those APIs as well. And then finally, if you have a team of DevOps engineers whose role is to deploy the models into production, then they will need permissions such as the create endpoint, or to create a model monitoring job, or to create a transform job, or invoke the SageMaker hosted endpoint. So now that we've seen how you can create these roles, your compliance requirements might require you to put some checks in place to ensure that the fine-grained access control mechanisms are not violated by a compromised user. In other words, how do you ensure that user A can only access the resources that are available to that user? Again, you can do this using IAM condition keys in conjunction with tagging. First, when you create the app, you will want to tag those apps with the user profile or the user ID of that federated user. Then you can create an IAM policy like the one that's shown here with the following condition key and attach that to the IAM principal that will be making these actions. This policy will check the user ID associated with the caller of the API and ensure that it matches the user ID that that particular app was tagged with. If there is a match, then the user will be granted access, but otherwise they will not. So your compliance needs, whether it's PCI or HIPAA or SOC, might all require you to protect your data. We have seen how you can control network access to your data using VPC and limit data access by user roles or job function using IAM. Now let's talk about KMS. Data protection or preventing data exfiltration is really a paramount requirement for regulated customers. For example, if you have a workload that's subject to PCI, you might want to consider separating storage from encryption, managing rotation of encryption keys, and so on. Now with machine learning, that requirement really extends to model artifacts, containers, model binaries, so there's a lot of moving pieces to think about. SageMaker handles a lot of the undifferentiated heavy lifting around encryption while still offering you the flexibility to include additional configurations. For example, API calls made to SageMaker APIs are always made over secure SSL connections, so your traffic is encrypted in transit. Similarly, if you don't provide your own KMS keys, storage that's attached to SageMaker training volumes, which is ephemeral, is encrypted with a particular key. SageMaker Studio also offers you functionality such as SageMaker experiments, which store your training metadata, your model hyperparameters, algorithm performance metrics, and so on, all of which are stored in a service-managed database, which is encrypted with a service key. So when it comes to data encryption at rest or at transit, encryption really comes out of the box with SageMaker. But if you now want to use your own encryption keys, you can certainly do that. You just need to establish the process. So let's take a look at one example. During training, here you can specify your own KMS keys to encrypt the training volume that is attached to your compute instance using the volume KMS key, as well as encrypt any training outputs using the output KMS key. Now for encryption in transit, if you're running distributed training, that distributed training traffic runs inside the SageMaker service VPC, and you have the option to encrypt that traffic as well. Additionally, using IAM condition keys, such as the SageMaker instance type condition key, you can also limit your machine learning jobs to only use the AWS Nitro instances. These instances are designed to protect the security of the customer data, even from the operators of that production infrastructure. Furthermore, to prevent data exfiltration, you can also consider using a tool like Workspaces, which is a desktops as a service solution for your data scientists to access the AWS cloud. Now, in addition to data, machine learning requires users to maintain code and packages, and a number of customers maintain those on-prem, using tools such as Artifactory or Nexus. Furthermore, in speaking with customers, many regulated customers such as yourselves have told me that they require even the notebooks to run only on cloud security approved base images, which go through your own vulnerability and scanning and security testing protocols. So let's discuss a concrete example on how you can build your approved container and bring that container to SageMaker Studio notebooks. First, you'll want to link your on-prem data center to AWS. Once you've made that linkage, using the SageMaker ENI, you can let Studio communicate with your on-premises code repos, for example, such as your enterprise GitHub or your Bitbucket. Now, a similar approach can be used to manage a package management tool like Artifactory or Nexus that lets your data scientist pip install approved packages into your notebooks without having to go to a public PyPI server. In addition to connecting package managers, next you will need to push your approved container images to Amazon ECR using the ECR VPC endpoint. And note that you can encrypt that as well using your custom key. Once your container is in ECR, you can use the SageMaker Create Image API to create a SageMaker image which uses your ECR container as the base image. You can attach the image using the CLI or the SageMaker UI. Data scientists will simply select that image using the custom drop-down menu and they're ready to go. In this way, you can ensure that only your security-approved container images are used to run Studio notebooks, and you can use on-prem tools to manage those container images yourself. Having seen how the security considerations from regulated customers can be implemented, a natural next question now is how you can automate the provisioning of these secure environments. Let's take a look at one architecture pattern on how you can do that using AWS Service Catalog. Service Catalog enables you to create products and distribute those products across accounts. You can also version those products using Service Catalog. So you can build a base environment which sets a base set of controls and then customize them as needed for different workloads. So a potential architecture pattern could be as follows. A data science admin can use the Service Catalog to provision a SageMaker notebook using the Service Catalog product, which will kick off a CloudFormation stack in the backend. Any relevant parameters that are generated in the CloudFormation stack as a result of the stack creation process can be stored in Systems Manager Parameter Store. Now, your data scientist can simply log into this notebook using a pre-signed URL, for example, and then they can use that Python file that we talked about to access these parameters without having to know their actual values. Alternatively, the data scientist could use SSO to navigate directly into AWS Service Catalog and choose from a menu of options what notebook instances they want based on the specific workload. Admins can have that base template in a shared services or an infrastructure account and then vend custom Service Catalog products based on specific workloads. So our final topic of today is going to be on auditability, governance, and compliance. Now with SageMaker experiments, you can easily trace the lineage of your training, processing, or your batch jobs and link that to the user profile or the IAM role of the user that initiated those jobs. So why is that important? Remember that example about the company that spent 2 or 3 weeks trying to trace their model's lineage? Well, if they had this tool, they could have identified who created the model, what their role is in the company, what the model metrics are, and where the model artifacts were stored. It could probably have saved them a lot of time. Earlier, we also talked about using tagging as a fine-grained mechanism for access control, using resource tags. Now let's talk about tagging as an auditability mechanism. In this case, you want to use tagging to let you audit what resources belong to a specific team or a project. In this case, you can use the request tag condition key, which requires an app or an experiment to be tagged as a project sandbox. If I now try to create another app with a different value, for example, the value production, I will now get an access denied error. So a common question that customers ask me is, should I put multiple teams in the same Studio domain or break up my Studio domain by teams? Now, while we recommend that you view the domain as a hard boundary and use account level isolation if possible, you can, by using this tagging approach, allow multiple teams to securely use the same domain. Additionally, if you want fine-grained access control down to the user level, note that each user profile that you create in SageMaker Studio can have their own IAM role, which is then used by Studio to call SageMaker and other APIs. Additionally, CloudTrail logs capture all user actions in SageMaker API calls. For example, in this case, the user profile named AppTester tried to create a Jupyter Server app, which was captured by CloudTrail. CloudTrail logs will capture user information such as what region that API call emanated from, the source IP, the AWS access key, and so on. Additionally, SageMaker is also deeply integrated with CloudWatch, and logs from SageMaker Studio notebooks, training, processing jobs, and other jobs are captured as CloudWatch in CloudWatch. This can further then be hooked on to alarms and notify administrators when resource state changes occur. For example, for Studio notebooks, you can use the AWS/SageMaker/Studio namespace to access your CloudWatch logs. Now, while we've discussed a number of security controls around protecting data for individual ML workloads, what happens when you scale to multiple accounts in multiple regions? Service control policies apply at the level of AWS organizational unit, and therefore all accounts within that OU can inherit a service control policy, which then defines the maximally allowed guardrails that all AWS accounts within that OU can inherit. So in this final demo, we're going to take a look at this service control policy and how it can be used to ensure that your SageMaker jobs, your training jobs in particular, are encrypted at rest with a customer managed key. So let's jump into that demo.
In this final demo, we will discuss service control policies. Here, I've attached the service control policy that we just talked about to all sub-accounts in my organizational unit. To see this, I can go to AWS Organizations and look for service control policies under Policies. When I click on Service Control Policies, I see that I have this Encrypt All Training Jobs Service Control Policy, and I can click on View Details. I can also see what accounts this particular service control policy is associated with. If I click on View Details, you see that this service control policy is called Encrypt Everything, and it denies SageMaker training jobs unless the output model artifacts are encrypted with a custom key. Now note that SCPs do not apply to root accounts, but only to the sub-accounts. And also remember that any condition keys that you would use are only allowed with deny actions for an SCP. Now, let's jump into the studio domain in a child account or a sub-account, and let's test this policy out. So here I am in my studio domain in one of the child accounts for which the service control policy has been applied. I'm going to kick off that same training job from earlier, but first I'm going to do it without supplying the custom key. As before, I initiate the TensorFlow estimator and I specify the TensorFlow estimator APIs. And you can see that nowhere here am I supplying an output KMS key. Let me now call the estimator.fit command and see what happens. And as you can see, we have a client error. When we scroll down, we see that the client error in fact has an explicit deny attached to this create training job, which is the service control policy kicking in. Now, let's kick off the training in the right way. This time we supply a volume KMS key, which is going to encrypt any EBS volumes that are attached to this training instance, but we also supply that output KMS key in order to encrypt the model artifacts. And let's call the estimator.fit again. This time we see that the training job can be initiated. Now note that SageMaker will automatically encrypt model artifacts and outputs with a SageMaker service managed key, but by providing you the option to manage your own custom keys, you have additional flexibility to meet your compliance needs, but you simply need to establish that process. You can see how service control policies are a great way to set those organizational level boundaries. Similar SCPs could be used to restrict training jobs unless appropriate networking controls are met. Now let's jump back into the slide deck.
Now, while SageMaker Studio is an IDE for your data scientists to build, train, and productionize machine learning models, for regulated industries such as the ones you're in, it is really important that these workloads comply with your existing IT standards and guardrails on data protection, network isolation, artifact management, and so on. In this talk, you've seen how SageMaker is deeply integrated with AWS security tooling, ranging from IAM controls with condition keys to provide user-segregated workspace and fine-grained authorization, end-to-end encryption at rest and in transit, customized keys with KMS for data and compute protection, and private networking with VPC. Additionally, with the option to bring your own custom containers, you can also make sure that the notebooks the data scientists are using only use your own security-approved container images. So it's really no wonder that with SageMaker, you can achieve over 54% total cost of ownership savings over 3 years compared to a do-it-yourself approach. So now you're probably wondering, how can I get started? So in the next 2 slides, I've provided a bunch of resources such as white papers, blogs, and hands-on workshops that you can use to quickly build and scale your secure machine learning environments on SageMaker. And these slides will be provided for you after this talk. So with that, I would like to thank you all for your time and have a great rest of your day.